Practice test number 2. Here we go. I'm going to show you how to graph these things. I'm praying that since this is the practice test, you actually know a little bit about how to graph them and not just blindly guessing, okay? So this one is in slope-intercept form. How do I know that? Because y is by itself. You ever want slope-intercept form, you get y by itself. Y by itself. And you will have it. Okay, so what you do with this is the slope is 2. The y-intercept is -1. This is the y-intercept. So what you do is you go down here. The y-intercept is -1. And your slope being 2, you're going to go up 2 over 1. You're going to go up 2 over 1. Up 2 over 1, just like that. And then I would recommend you grab a ruler. In fact, let's try and use the ruler in this thing. Ooh, here we go. I don't even know if you can see me using the ruler, but I don't often use it. Here we go. I think that looks good. Let's try and use the ruler. Wow, that's cool. All right, see you later, ruler. This is number 1, the blue one. Okay, number 2. This is in point slope form. What the heck is point slope form? It's this, where this and this are your point, and this is your slope. And if you're confused on why this and this are your point, well, it's because points are all made up of an x and a y, okay? So our x and our y, well, here's the x, right there, it says +6. Well, what would you plug in here to get a +6 here? Well, it would actually have to be -6, okay? Because a -6 would be +6. And in fact, why would it be negative? Because if you took -6 and plugged it in right here, that negative's already there, okay? That's what makes that positive. And then the other one is going to be 4, a +4. Because check this out, this is already negative to begin with. So what would you put here to keep it being a negative? You have to put in a positive number. So there's our point, and then our slope is just right there. Our slope is 1/3. So we're gonna do this one in yellow, why not? So our point is -6, 4. Start at the origin and go over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4. And now I'm going to erase all that because I want this to not look crazy. Then our slope is 1/3. We're going to go up 1 over 3. Up 1 over 3. Up 1 over 3. You can do that as many times as you want. And there we will have our line. Let's do the ruler. Since I apparently can use the ruler now. All right, ruler, here we go. So this one is number 2. All right, number 3. This guy is in standard form, which looks like this. AX BY equals C. Now I'm going to say this. This is not your x-intercept. This is not your y-intercept. This helps you find them easily, in my opinion, and here's how you do that. You basically plug in 0, okay? So here's what you do. If you plug in x is 0, then x is 0. There's nothing there now, because 4 times 0 is 0. 0 plus 2y is 2y. So you can now solve that to just say, when x is 0, y is 6. You have now found what we call the y-intercept, okay? But now I'm going to erase that because it does exist, right? And now I'm going to find the x-intercept. How do you do that? Well, it's when y is 0. So check this out. When y is 0, it's gone because 2 times 0 is 0. 4x plus 0 is 4x. And you can now solve that by dividing by 4, and you get that x is 3. So check it out. You have found 2 points on the graph. And that's all you need in order to graph a line. So let's see, what color should we do this one in? We did blue and yellow, let's go red. All right, we said X is 0, Y is 6. 1, 2, 3, 4, 5, oh look, they overlap there, that's great. So that's 1 point, and the other is X is 3, Y is 0. 1, 2, 3, right there. So if you're like, well, okay, now what about the slope? Yeah, what about the slope? I don't see why I should use a slope when I have 2 points, right? So here we go. Let me straighten that up just a little bit, tiny more. That's good enough. Okay, by ruler, zoom out. This is number 3. We'll do the next one in purple. Purple. Oh, look. It's slope-intercept form again. Y equals mx plus b. So it might help if we rewrite this to look like this, just because when it comes to slope, seeing it like that is very nice, because it is the change in y over the change in x, also known as rise over run, yeah? So we're going to rise -3, run 5, but you know what, we'll see. So let's go down here. All right, 1, 2, 3, 4, 5, 6. There's -7. Our slope was -3 over 5, so we could go down 1, 2, 3 over 1, 2, 3, 4, 5. And one of the reasons why I bring up that, well, it kind of depends, is because if you wanted to go down 3, you'd be off the graph now, and that's okay. But we could also go the other direction. We could go up 3 and back 5, like that. Let's see, 1, 2, 3, 4, 5. You could do that. So let's erase these dots just to kind of keep it clean looking. All right. Let's zoom out of here. Let's grab the ruler. Good enough. Let's go. And this one is number 4. Yep. All right. Number 5. Love number 5. There is Vux and Hoy. That says how. Hoy. This is a vertical line, has an undefined slope, and it's going to be x equals something. This is a horizontal line, has 0 slope, and it's y equals something. So if we have y equals 4, you just go here where y equals 4, and you draw a horizontal line. Here we go. That is number 5. And last but not least, we have x equals -4. That's Vux. It's a vertical line because it's an undefined slope, and it's x equals. So where does x equal -4? Right about here. Grab the ruler. 90 degrees. Here we are. And this is number 6. We've officially graphed all 6 of those. Explain 2 different ways you could take the following equation and graph the line, then graph the line. Well, this is number 1 in point slope form. So I could find my point from it. And that point, if you're not sure, would look like this. It's y minus y1 equals m times x minus x1. So here is part of my point. Here is another part of my point. So my point is x is 4, y is -5. Not sure why it's negative and positive the way it is. This is a positive 4. If you were to place a positive 4 right here, a negative x, well, it would stay negative, right? If you were to take this negative 5 and place it right here, a negative 5 would be a positive 5. So that's the first step of this. And then also find my slope, which is right here. So, and then you just graph it from there. Like, I'm not going to explain, now you graph it. So 4, negative 5, so there's 4, 1, 2, 3, 4, 5, and the slope was, what was it, 1/2, up 1 over 2, up 1 over 2, up 1 over 2. So there we go. We've done more than half the problem now, because we were just told to tell 2 different ways we could do this. Tell 2 different ways we could do this, and then just graph it. So there we go. Sorry, I screwed up the graphing a little bit, but there's the graph. And then now step 2 is I could rearrange this into, and then now here's where you have some choices. You could do standard form, you could do slope-intercept form. I'm gonna do slope-intercept form, which is y equals mx plus b. So let's do that. I'm gonna just come up here and do it. Hang on, I'll do it up here. Y plus 5 equals 1/2 times x minus 4. I would distribute the 1/2 to get y plus 5 equals 1/2 x minus 2. And then I would subtract 5 to get y equals 1/2 x minus 7. And from that, I have my y-intercept and my slope. And so the y-intercept would be at -7. So let's see if it is. 1, 2, 3, 4, 5, 6, -7. And the slope is still 1/2. Up 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. Still works. So boom, that is 2 different ways you could do that one. Explain 2 different ways you could do this one. Well, first I would, so number 1, I would find my x-intercept. And I'm also going to write find my y-intercept. And the reason I'm doing that is because this is in standard form. And standard form looks like this. ax plus by equals c. And no, the x-intercept is not 4. No, the y-intercept is not -2, okay? This just kind of helps you to find it, because to find the x-intercept, you do y equals 0. So when y is 0, you find that x equals 2. How do you do that? 8 divided by 4 is 2. And so what I'm going to do now is erase this part, because I need it in order to do this part. To find the y-intercept, you plug in 0 for x. So there's me covering up my x. Why am I covering it up? Because when you plug in 0, it's nothing. 4 times 0 is nothing. 0 minus 2y is minus 2y. And then I solve by dividing by -2, and I get -4. And then from there, I literally just graph it. So again, I'm not going to say the thing of, well, now you graph it. I'm just going to go over here and do it. The x-intercept is 2. The y-intercept is -4. And here we go. I guess since I have chosen red and yellow, I will grab orange to graph this thing. There's the graph. So there's the graph. Another way this could be done, so a second way, is rearrange to ... For this one, it makes the most sense to me to put it in slope-intercept form. Up here, I mean, I had choices. I could have put it in standard form. I've just done this long enough and talked to enough people that they're like, no thanks. Not unless I have to. So here we go, rearrange to y equals ms plus b. So we had 4x minus 2y equals 8. Over here, what did I tell you about this? Slope-intercept form is just get y by itself. So let's do that. I'm going to subtract 4x. I'm going to divide by -2. And you know what? I'm going to write it out so that you see what I just said. And I get y equals 2x minus 4. So let's jump up here. Our y-intercept is -4. Our slope is 2. We go up 2 over 1, up 2 over 1. Nailed it. So there is explain 2 different ways to graph that one. Now we are given some info and we're going to write an equation of the line, but in the end, your answer should be in slope-intercept form, which is y equals mx plus b. So, given 2 points, 3, -1, -2, 14. Here's the thing. There are different ways that we could do a lot of these, but pretty much, guys, we're going to be using a combination of point-slope form. We'll be using slope in general. That looked ugly. Let's try it again. y1. So this is just slope. This one is point slope. Wow, I'm really having trouble writing slope. And then slope intercept, which I already wrote a second ago, is just y equals mx plus b. I'm pretty sure these are the only 3 we're really going to be using. Because standard form is just, unless they give us capital A equals and capital B equals and capital C equals, I'm probably not going to use those. So scratchity out. Bye. Given 2 points, well, I'm going to find the slope of those. So y2 minus y1 over x2 minus x1. I get 14 plus 1 is 15. -2 minus 3 is -5. My slope is -3. Y minus y1 equals m times x minus x1. Y, hold up, let's do it in green. Y minus equals, so here's what I'm doing is I'm copying everything that doesn't change in green, plugging in what I know now. So my slope is -3. My point, I have 2 to choose from. I like that one better. It seems easier to work with, so I'm going to do that one. The x is 3. The y is -1. -1. If we were looking for point slope form, I'd be done, but we're not looking for point slope form. We're looking for slope intercept form. So what I'm going to do is simplify. That's y plus 1. I'm going to distribute the -3, and now I'm going to subtract 1, and I get a large area. So hang on, let me zoom in and do this. Y equals -3x plus 8. We have a vertical line that passes through this point. I love it, because vertical lines are VUX. And if you're like, what the heck? VUX and HOI. I've talked about it at least once already in the video. Vertical lines have an undefined slope. Undefined meaning it's going to be like 3 over 0, and you can't do that. That's undefined, and it's going to be x equals a number. So, dude, this one is literally just x equals 2, and we're done. Because no matter what the y is, x is going to be -2. That's it. Number 11, a line that has an x-intercept of 6 and a y-intercept of -2. Now, this is the part where I was like, maybe you might think it's going to be this. I'm still not doing that, okay? Instead, what I'm going to do is the x-intercept is 6, 0. The y-intercept is 0, -2. I'm going to do point slope form again. I'm going to find the slope, -2 minus 0 over 0 minus 6. That's 1/3. That's my slope here. And then I'm going to do y minus y1 equals the slope minus times x minus And you might be like, wait, what is this yellow business? There's lots of holes in it. I just did this one right here. So go back and watch that one if you're not sure. Pick a point. Why not that one? X is 0, Y is -2. And to put this in the slope-intercept form, we're going to simplify. This is Y plus 2 equals 1/3 X. Subtract 2. Done. Number 12 goes through the point 2, 5 and has a slope of -2. I love it. Y minus, that's our X, that's our Y minus 5 equals -2 times X minus 2. Dude, we are so much further along than we were on some of those others. We're going to distribute the -2. We are going to add 5. We're done. 13 is parallel to this line and goes through this point. Aha! We need that slope because parallel lines have the same slope. So this is our new slope and it's our old slope. And now we're going to do y minus y1 equals the slope times x minus x1. Well, there's our new slope. Here's the point we need. X is 1, y is 2. And now we're just going to simplify this. Y minus 2 equals 2/3 x minus 2/3. And you might think, oh man, we got to do fractions. Yeah, you do. Y equals 2/3 x. And then how are you going to do this? Well, if you don't know, you could say it's plus 1 1/3. You can kind of tweak it if you want. -2/3 plus, let's see, 2 times 3 is 6/3. That's 2. And so this could be 4/3, right? So however you want to write this, there it is. Number 14, perpendicular to this one and goes through that point. Okay, if our old slope is 1/4, our new slope is going to be -4. Why? Because perpendicular slopes are negative reciprocals. I don't know what this little curly thing became, sorry. Anyway, negative reciprocals, okay? So if it was 1/4, it's now -1/4. So guess what? Y minus y1 equals the slope times x minus. So our slope was 1, not 1/4. Haha, fell into my own trap. -4. Our point, the x is 2, our y is 0. Man, this one is so much faster than the others, kind of. You distribute the -4 and you get -4x plus 8, and then this 0 just is done with. So there you go. Has a y-intercept of -2. Well, guess what? That is, oh, you know what? I was about to fall into doing point slope form, but I don't need to do that. See ya. Y equals 5x minus 2. Slope-intercept form knows the slope, and it knows the y-intercept. Easy. 16 has an undefined slope. Well, guess what? We just had one. Ooh, vertical line has an undefined slope. Guess what? That's Vux. Vux is a vertical line with an undefined slope, and it's going to be x equals a number. It is going to be, I'm guessing there's kind of a typo here. So however you want to say it, it's either x equals 2, unless they meant for that to be -2, in which case it's one of those. You get the idea, right? Word problems, yeah. Lyle needs to buy 120 beverages for a party. That's the total. Almost every time I do something with a word problem, if I'm given a total, I'm writing equals the total. And now I'll read the second sentence. What equation in standard form, so it's going to be like this, determines the number of x, determines the number of x of 8 packs. So, okay, that's going to be an 8-pack. And this is going to be a 12-pack of water. And so now rewriting this, it's going to be 8x plus 12y equals 120. And you might think that you need to solve it, but I read this question a few times, and all it just says is what equation in standard form determines the number. So let's call it good right there. For what values of k are the graphs y equals x, 3x plus 4, and 2y equals kx plus 9 parallel? So let's check this out. If these two are going to be parallel to each other, then their slopes need to be equal to each other. And where this takes there's already kind of a curveball, and then they put the k there, right? That's a little tiny curveball. It gets a lot curvier because of that 2, all right? So what I'm going to do is I'm going to solve this for y. And if you're thinking, wait, what do you mean by solve it for y? Well, there was a 2 in front of it, so I'm going to divide by 2. And so it would look like this. Oops. 9/2, right? And then we have our original one here, which is y equals 3x plus 4. So what needs to happen is this needs to equal that. So when does k/2 equal 3? That's the question we're answering. We're going to multiply both sides by 2 and get 6. And that's it. There is no other value that's going to work. I know it says for what values, but it's that the slopes have to be equal to each other. So if you put 6 right here, then that's how it's going to work out. There's nothing else going to affect that other than except for maybe the number in front of the y, but that's not going to change. In a certain lake, a 1-year-old, let's do some highlighting here because there seems to be a lot of words. A 1-year-old bluegill fish is 3 inches long. A 4-year-old bluegill fish is 6.6 inches long. Assuming that the growth rate can be approximated by a linear equation, write an equation in slope-intercept form. We want slope-intercept form for the length L of a bluegill fish in inches after t years. Then use the equation to determine. Okay, so here we go. If I'm having 1-year-old is 3 inches long, this would be T, and this would be L. Okay, and so we have another version where a 4-year-old is 6.6 inches long. And again, this is T, this is L, okay? So basically, we're going to find a slope from this information. 6.6 minus 3 over 4 minus 1. Well, this is 3.6 over 3. So our slope is 1.2. And then to give it some context, remember, this is the change in y over the change in x. But our y and x are here. So it's going to be the change in length over the change in years. It's going to be 1.2 over 1. If you want to, I think that works. You could do inches over years if that helps. But really, I just wanted to this is what I was most interested in. Okay, so we need an equation in slope-intercept form. Okay, well, then we're going to do point slope form first. So it's going to be y minus the slope times x minus, and then I plan on using this one because it just looks easier. So our y is 3, and our x is 1, and our slope was 1.2. And then technically speaking, we want to erase this and not call it y, but call it L. And we don't want to call that x. We want to call it t. And now we're going to solve for L. All right, so we will distribute 1.2 there and there, and I'm gonna do it kind of out over here. So we're gonna get L minus 3 equals 1.2 T minus 1.2. We're gonna add 3 to both sides, and we get that L equals 1.2 T plus 2.8. Nope, 1.8. So, let's see if any of this makes sense. What we're saying here is that a fish that's just born, 0 years old, is 1.8 inches long. And that sounds okay, given that a 1-year-old is 3 inches long. And, okay, so we have done everything. Last thing we need to do is determine the age of a 9-inch fish. So first thing is we can go ahead and circle this. We have done, that's part 1. And then now we want a 9-inch fish. Well, we're gonna put that in for length. So 9 equals 1.2 time plus 1.8. We will subtract 1.8 to get 7.2. We'll divide by 1.2, and let's see, that's 6. So at 6 years old, a fish will be 9 inches long. So 6 years old. All right, next. Explain how you can determine if the graphs of that and that are either parallel or perpendicular. Well, I guess my mind goes to a couple things. Is one, we could just say they're parallel if they have the same slope, and then they're going to be perpendicular if they have negative reciprocal slopes. Okay, so that was my first thought, is just to say, okay, well, that's what, but I'm guessing that number 2 is going to be like, okay, well, not only just explain how, but do it. So we have y equals negative 2x minus 11, and x minus 2y equals 12. So if we were to explain how we could know from here, is the first thing that I would do. So now I'm going to put like a, because here's my first point underneath this, is I could solve for y to get slope intercept, which gives us slope easily. So how do you do that? X minus 2y equals 12. I'm going to subtract x and divide by negative 2. And I get positive 1/2 x minus 6. And then I can bring down the other equation, y equals negative 2x minus 11. And then I can say that these are perpendicular to each other because of their negative reciprocal slopes, and therefore they would not be parallel. I guess the one other thing that I could do is, so here's my B to that being A. B is graph them. The first equation is in slope-intercept form, and the second one is in standard form. So the reason I'm even writing that down is because I'm about to graph them. So here, I'm going to copy these guys. Oops, that's the pointer. Here's the cutting tool. I'm going to copy these guys and bring them down here. And if you're thinking, that seems overkill, really I just want to approach this like from the most nitpicky way possible and then go from there. So this one will be red. Its y-intercept is -11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's -11. Its slope is -2. So it's going to go down 2 over 1, down 2 over 1 right there. And I can graph it. About right there. And then the other one, let's make it green. Since it's in standard form, what I'm going to do is I'm going to find the the y-intercept by getting rid of the x. So divide by -2, and the y-intercept is -6. So 1, 2, 3, 4, 5, 6. Right there. And then go back up here and erase. Because now I'm going to find the x-intercept. And it's just 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I didn't put my dot, but it is on there. But it will be there here in a second. As I graph that, they look fairly perpendicular to me. Obviously, this is not a perfect graph, but that looks pretty perpendicular, and then we kind of proved it already up here. So when I say you could graph them, alongside that is to find slopes. So there you go. I kind of overkilled that last one. Let me know what questions you got about this. See you later.